When we come to the groups after the transition metals, we see much more variation in the behavior of elements within a group. We see a pronounced transition from nonmetals to metals within group 14. The group starts with carbon, a nonmetal, and continues with silicon and germanium, which are both metalloids, like boron, ending with the metals tin, lead, and the still unnamed element 114. Carbon is a nonmetal. Its valence electrons are too tightly bound to form an electron C. In its diamond form, carbon does not conduct electricity at all. All of the valence electrons are locked into strong covalent bonds. Each atom is connected by these bonds with each of its 4 nearest neighbors. The bonds lock each atom tightly in place, making diamond exceptionally hard. So why do we see nonmetals, metalloids, and metals in the same group in this part of the table? An element can behave like a metal only if its electrons are easily removed. As we go down a group, the atoms of an element get larger and the valence electrons are pushed farther and farther away from the nucleus. The more distant electrons are from the nucleus, the easier they are to pull off, and the more metallic the behavior of the element will be. Elements become more and more metallic as we go down a group. This is exactly what happens in groups 13 to 16. Let's look at an example. Group 16 shows increasing metallic appearance from a colorless gas to yellow powder to a grayish metalloid to a metallic solid. We've seen that elements display an incredible range of behaviors. The periodic table arranges the elements so that we can recognize trends in element structure and reactivity using simple models. The location of an element on the table is based on the element's behavior, especially how it reacts with other elements. By studying the periodic table, we can see trends in the behavior of elements. Using the table to understand these trends gives us the ability to learn more about the chemical world around us and helps us predict what will happen next.